Our planet Earth is in constant motion. It orbits the Sun, our star, and it also spins on its own axis. This spinning is what we call Earth's rotation. Imagine a basketball spinning on your finger. That's Earth rotating, except instead of a finger, we have an imaginary line called the axis. This axis runs through the Earth from the North Pole to the South Pole. Earth rotates at an incredible speed of roughly 1,000 miles per hour. That's faster than most airplanes. But we don't feel it because everything around us is also moving at the same speed. This continuous rotation is a fundamental force that shapes our lives in countless ways, from the rhythm of day and night to the patterns of our weather. The most obvious effect of Earth's rotation is the cycle of day and night. As the Earth spins on its axis, different parts of the planet face the Sun. The side facing the Sun experiences daylight, while the side facing away experiences night. It's like turning a flashlight on and off on a spinning globe. This rotation takes approximately 24 hours to complete one full cycle, which is why we have a 24-hour day. This cycle of light and darkness is fundamental to life on Earth. It dictates our sleep patterns, influences the behavior of animals, and even affects the growth of plants. Earth's rotation plays a crucial role in shaping our planet's weather patterns. As the Earth spins, it doesn't heat up evenly. The equator, the imaginary line circling the Earth at its widest point, receives the most direct sunlight. This makes the equator hotter than the poles. This temperature difference creates air currents as warm air rises at the equator and colder air from the poles rushes in to replace it. These air currents, combined with Earth's rotation, create the complex and dynamic weather patterns we experience. From gentle breezes to powerful storms, Earth's rotation is a driving force behind our ever-changing weather. Earth's rotation is also the reason we have different time zones. Because the Earth spins, the Sun rises and sets at different times in different parts of the world. If we didn't have time zones, things would get very confusing very quickly. Imagine trying to schedule a phone call with someone on the other side of the world if they were using the same time as you, but it was the middle of the night for them. To avoid this, we've divided the Earth into 24 time zones, each one representing a slice of the Earth that experiences roughly the same time of day. As you travel east or west, you move through these time zones, adjusting your clocks accordingly to match the local time. Our bodies have their own internal clocks known as circadian rhythms. These rhythms regulate our sleep-wake cycles, hormone release, and other bodily functions. Amazingly, these internal clocks are synchronized with Earth's rotation. The cycle of light and darkness acts as a powerful cue, telling our bodies when to be awake and alert and when to rest and repair. This synchronization is why we experience jet lag when we travel across time zones. Our bodies are still operating on their old schedule, out of sync with the new time zone. It takes time for our internal clocks to adjust, and we may feel tired, disoriented, or experience other symptoms until they do. One of the more intriguing consequences of Earth's rotation is something called the Coriolis effect. This effect describes how objects moving over a rotating surface, like the Earth, appear to curve off their intended path. Imagine trying to roll a ball in a straight line across a spinning merry-go-round. From your perspective on the merry-go-round, the ball wouldn't travel in a straight line but would curve as it moves. This is similar to what happens on Earth. The Coriolis effect influences the movement of large-scale systems like air currents and ocean currents, causing them to deflect to the right in the northern hemisphere and to the left in the southern hemisphere. The Earth's rotation isn't constant, it's actually slowing down very gradually over time. One of the main reasons for this slowdown is the gravitational pull of our moon. The moon's gravity creates tides in Earth's oceans. As these tides bulge out, they create friction against the rotating Earth, slowing it down ever so slightly. Don't worry though, this slowdown is extremely gradual. It would take billions of years for Earth's rotation to slow down significantly, but over millions of years, this effect has lengthened our days. Earth isn't the only celestial body that rotates. In fact, nearly everything in space spins. Our sun rotates, the planets in our solar system rotate, and even galaxies rotate around their centers. Rotation is a fundamental property of the universe. and it plays a vital role in the formation and evolution of stars, planets, and galaxies. By studying the rotation of other celestial bodies, astronomers can learn more about their composition, history, and the forces that shape the cosmos. Here are some surprising facts about Earth's rotation. The Earth's rotation is not perfectly uniform. It wobbles slightly on its axis due to the gravitational pull of the Sun and Moon. If the Earth were to suddenly stop rotating, the inertia would be catastrophic. Everything on the surface would be flung eastward at incredible speeds. Scientists believe that Earth's rotation was likely much faster in the past, with days lasting only a few hours. The Moon's gravitational pull has gradually slowed down our planet's spin over billions of years.